Alex Jafari. I am here with you to go over the homework from section 3.2 Methods that Return Objects. Once again, these are from the book AP Computer Science Done Right, and it's available on Amazon if you want to read it as an ebook or as a hardcover. Irfan, are you ready to finalize the homework, sir?
Let's do it. Let's do the homeworks.
Excellent. So the first homework is that people normally measure their food's weight in grams or ounces. However, it's Thanksgiving and all sense of food measuring is lost. So people want to learn how much they've consumed in number of turkeys and feathers. So instead of saying, oh, I had a kilogram of something, they want to say I had half a turkey or I had a turkey and a few feathers. The conversion is that each turkey is equal to 2 kilograms and each feather is equal to 100 grams. So we want to design a method that, given a weight in grams, it returns turkeys and feathers. Okay?
Okay.
What is this most similar to in terms of what we learned in class?
Sorry, I didn't hear you.
What is this similar to in terms of what we learned in class? In the previous video, when we went over a few things in class, what is this similar to?
I think it's similar to the height conversion
Exactly. Yeah.
problem.
Yeah. So we had the height in centimeters, and we wanted to return feet in inches, right?
Okay.
So we created a new height class, and it had the feet in inches. So this is like very similar as you said. So how do we get started on this? What is the first thing we want to do?
I think first we need to create a class food,
Uh-huh.
which has two fields of turkey and feathers, and they're both going to be an int, I think.
Okay. Instead of food, however, I would call it perhaps weight or food weight. Since it's not food, we're not describing food. We already have a food class actually, but we're actually just describing weight, right?
Yes. So food weight.
Perfect. So we can do this. Normally you would create a new file, so we would say class food weight, and you said it would be two ints, so int turkey and int feather, right?
Exactly.
And then the comments, once again, never forget, it's going to be 2 kilogram. And this is going to be equal to 100 grams, right?
Exactly.
What do we need here?
The constructor.
Exactly. So we're going to do food weight and turkey and int feather. This dot turkey gets turkey, and this dot feather gets feather. Alright, great. Now we have our food weight class. Perfect. Done with this. Now it says, design a method that, given a weight in grams, returns turkeys and feathers. What's the first step of designing a method?
It's the purpose statement.
Purpose statement, exactly. What is the purpose of this method?
Conversion of weight to grams. Conversion of a given name into grams.
Okay, so it's not going to be into grams, it's going to be into turkeys and feathers, right? So converts given grams to weight in turkeys and feathers, right?
Right.
Excellent. What's our signature? What's our input and output?
Mm, mm, we're in the class food weight, so I think we don't need to fill any inputs.
No, we're not in a food weight class.
Or we're not.
No.
So it's going to be an output, which is an int.
Sorry. So what are we taking in and what are we giving out? What is the taking in? Input?
We're taking in the food weight. So it's gonna be an int.
Not this food weight, right?
No, not that one, but
Okay, so
the given one.
So we should rename this class because of turkey. Let's call it this. Food weight in turkey. Okay. So we're gonna take in the weights in grams, right?
Exactly.
Right. So it's gonna be an int. And what's the output?
It's also going to be an int.
It's gonna be an int.
Yes, isn't it? Because it's gonna be numbers of turkeys and feathers.
Let's go through an example. Let's say I had, let's say 3,400 grams of food. So what should my method take and what should it return?
It should take the 3,400, and the output will be numbers of turkeys and feathers. Like two turkeys, for example. Is that right?
It's gonna be less than that because it's gonna be.
Yeah.
Let's make it 4,400. Okay. So you're saying it should be returning what?
Like okay, now I get this. It's gonna be like 2 point something, but it's gonna be a decimal number, so we need a double there. Is that right?
So what I'm confused about is that we created this whole class, food weight in turkey. So why would we use different types? Because remember when we used the height example, the output was the new height class that we created. So in this section we learned that we don't need to return integers or doubles or strings. We can return different classes that we make.
All right. Yes.
Right?
Mm-hmm.
So we can make our return type be food weight in turkey. That's our return type.
Okay.
Right? So then that would return a food weight in turkey that has 2 turkeys and 4 feathers.
Okay.
Does that make sense?
Yes, it does.
Okay. Otherwise, if you're going to do a double, then you don't need this class. Then this class wouldn't exist.
Yes, it makes sense.
Okay, great. All right, now that we've gone through the example and we have the signature down, how do we convert this signature into a code?
So, food in Turkey,
Food weight in turkey.
food weight in Turkey.
Yep.
There is no input, so an empty parenthesis.
We need the function name, right?
Oh yeah, it's going to be what?
Convert from gram to turkey. So this is our signature. And we know that it definitely expects a return statement, right? That's going to
Right.
be food weight in turkey. So initially, we know that turkey weight is going to be 2,000. And feather weight, it's going to be 100, right?
Right.
And we have the grams input. So all we need to do is say int turkeys gonna get the grams divided by turkey weight, right?
Exactly.
So if it's going to be 4,400, if we divide it by 2,000, we're going to get 2.2. But since it's an int, it's going to get rid of the point whatever. So it's just going to be 2. And then for feathers, we're going to use something called modulo, which means taking the remainder. So we're going to take grams, remainder of turkey weight, remainder. So this essentially is going to give us 400. Okay?
Yeah, exactly.
So it's going to give us 400, but that's not feathers, right? That's just the remainder. So then we're going to say feathers is going to get feathers remainder divided by feather weight. Let's walk through this one last time. Let's do a different example. Let's do 3,600. Okay?
Okay.
So the turkey weight is going to be 2,000 and the feather weight is going to be 100. Our grams is going to be 3,600. What is 3,600 divided by 2,000? It's going to be 1 point something, right?
Exactly.
So since it's going to be 1 point something, it's going to just round it down to 1 because it's an int. It's a whole number.
Yeah.
Right? So it's going to be 1 turkey. Okay. 1 turkey. Great. Then it's going to care about the remainder. So the grams being 3,600 modulo of 2,000, it's going to be the remainder, which is what? 1,600, right?
Mm-hmm. Yeah.
Does that make sense? Because 1 turkey is 2,000. So 3,600 minus 2,000, it's going to be 1,600.
Yeah.
Then it's going to take this 1,600 and it's going to divide it by 100. So it's going to get what?
16.
16, exactly. So then we can return a new food weight in turkey, and it's going to take in turkeys and feathers. That's it. I'm going to delete these because it's
Perfect.
an example. All good?
All good.
Excellent. And this can, exist in any of the classes. It can exist in the food weight in turkey class, or it can exist in the food class.
Makes sense.
Excellent. The second question is that a local boba tea place has a cash register, and the cash register has how many cents the customer is owed. They need to know how many quarters, dimes, nickels, and cents they should give. So let's first go through our definitions. So a quarter is 25 cents. Dimes are 10 cents. and nickels are 5 cents. And cents are obviously 1 cent. Okay?
Okay.
So let's go through an example. Let's say a customer is owed 135 cents. What should our method return?
You should return like 5 quarters.
5 quarters. So that's going to be 125 cents.
And a dime.
And a dime. Okay. What should our input be?
Input is 135.
The type. What is the type of 135?
Oh, it's an int.
An int, excellent. What should our output be?
It's also an int.
Is this an int?
5 quarters and a dime.
What number is the same as 5 quarters and a dime?
135.
No. I'm saying this is clearly an int. It's just one number, right? How do I represent this as a number?
So it's going to be a double.
How do I represent this as a double?
I don't get the question.
So our idea is to represent information as data, right? So if I tell you I weight 160 pounds, let's say, then the data that you would use is int 160 pounds, right? 160 is the int that you would use. Whoops. Right?
Yeah.
Okay. I'm saying if you're telling me 5 quarters and a dime, how do you represent this? What is the data that you're getting?
Oh. Are we going to write that as like letters?
What do you mean?
Like here you wrote 5 quarters. And quarters is with letters.
So what is the type?
It's a string.
Okay, so you want to have a string that is like 5 quarters and 1 dime, like this.
I think so.
Okay. What did we say about strings last class?
That they should not be used as outputs.
Not that they shouldn't be used as output, they shouldn't represent data, right? There's always better ways to represent data. Instead of representing it as a string, what else can we do?
Or no, there's int, there's double, and there's a string, and...
Right, so we said you can either use the primitive types like int, double, and string, but when information is complex, what do we use?
We call it from another class?
Right, but what do we use to represent the information when the simple ones are not sufficient?
I don't know.
So complex informations are represented with classes, right?
Okay.
So similar to how we did it here and how we did it in height, we can have a class, right?
Okay.
So let's have a class coin, and it will have quarter which is 25 cents. Dime, which is 10 cents. Nickel, which is 5 cents. And cent. And pretend we have a constructor for it. Then, for this question, we can say the purpose is convert cents to coins. Quarter, nickel, dime, and cents. And the input is going to be an int, which is a cent. The output is going to be a coin. So to code it, we could be coin, convert from cent, and the input is going to be int cent. Let's call it input cent. Does this make sense so far?
Yes, it does.
Okay, great. So yeah, we always want to check if what we're returning is something super simple, like a number or a name, then we know what to do. If it's anything more than that, we want to create a custom class, and we want to return that class as a type. So now how can we do a similar logic to here?
There you go.
What's that?
I said, I don't know.
So we first can divide it by 25, right? So let's go for the example that we said. You knew that 135 cents is going to be 5 quarters. So that means we initially use input cent divided by, oh, actually it's better to have the local variables too. So int quarters gets quarter is 25 and dime is 10.
In the class coin, can't we just like define these numbers there? Because they're always the same.
Yeah, that's a great point. So we'll learn later on how to define these things in the class and use it. It depends on whether or not we're going to, if we're going to have it in this class or not. So what you're essentially talking about is called constants. So these are constants because they're constant. They're always going to be the same. And it's an excellent point that we should always have the constants in one place instead of like changing it in one or the other. But right now we haven't learned it yet, so we're just going to have it in this one method. Does that make sense?
Okay. Yes, it does.
Perfect. So then we'll divide the input cent with quarter. So that's going to give us 5, right?
Yeah.
And then dimes is going to be quarters modulo input cent modulo quarters. So this is going to be 130 divided by 25, which is why it's going to give us 5. This one, it's going to be 130, right? That was our example. 135, sorry. 135 of modulo 5. going to be the remainder of it. And the remainder of it, it's going to be 10. Right? Because 5 times 25 is going to be 125.
And 10 dimes are going to remain?
No. It's the remainder of quarters.
Oh, yeah.
Right?
Okay.
So then dimes are going to be dimes remainder divided by dime. And that's going to be 1, right? 10 divided by 10.
Yeah.
The rest are going to be 0 for this example. So let's think of a different example. Can you give me a different input cent?
Let's say 143.
Okay, let's say 143. So it's going to be 143 divided by 25, which is going to be what?
5.
Yeah.
It's not going to be
exactly.
6.
Exactly. So it's going to be 5. So that's going to get us up till 125, right?
Yeah.
Okay. What is going to be the remainder of this?
So 143 divided by 5.
It's going to be, so.
Oh, sorry. Yeah. It's going to be 18.
18. Great. So then, what is 18 divided by 10?
1.
1, exactly. Then we're going to calculate the remainder of that. So int Nichols remainder. And it's going to be input cent. Well, actually, it's not going to be the input cent. It's going to be the dimes remainder modulo dimes. Right? Or nickels.
Mm-hmm.
Dimes or nickels? Dimes. This is going to be essentially 18 minus 10. Right?
Yeah, so 8 is the Nichols remainder.
Exactly. So then the Nichols is going to be Nichols remainder divided by nickel. And that's going to
Which
be...
is 8 divided by 5 and is 1.
Exactly. And then we're just going to have cents, right?
Yeah.
That's going to be nickels modulo nickel, right? What this operation does is that it divides the two numbers. Okay, great. So now how do I return?
Return. Quarters plus dimes plus nickels.
What is the return type?
Return coin.
Return new coin.
New coin.
And it takes in quarters.
The sum of all these, yeah.
It's not going to be a sum. It's going to take all of these things as a separate field, right? Just like when you created a new person, and it's going to be person name, person's height, weight,
Oh, yes.
and favorite class, right? Great.
So let's do an example, if possible.
Yeah, absolutely. Which example do you want to do?
You say number, we see if it works.
Okay, great. Well, first of all, I think we should have a test, right?
Oh, yes.
So, for a test, I actually don't know how to make. Oops. I don't know if testing in here is just as easy as IntelliJ. It might not be. But the test should be for example, 143 should return a coin of 5 quarters, 1 dime, and 1 nickel and 3 cents, right?
Exactly, yes.
Excellent. All right. Let's do something else. Let's say I have 21. What should this return?
Should return 5 quarters? No. Yeah, 5 quarters and a cent.
21, not 121, 21.
Oh.
I just have 21 cents. How many quarters is that?
Quarter was 25?
Yeah.
So it's gonna be 2 dimes and a cent. 0?
Yeah, 0, exactly. So then it will do a remainder of it. What is the remainder of 21 divided by 25?
0 again.
The remainder is going to be 21, right?
21 divided by 25?
21 divided by 25 is 0, but its remainder is going to be 21, right?
Okay.
The reason why that works is that the way to get remainders is you multiply whatever you got by what you're dividing. Okay? So 0 times 25, what is that?
0?
Exactly. So I still have 21 left.
Okay.
So if it was, let's say if it was 2, let's say somehow this added up to 2, then how many would I have left?
21 times 2? No, where was 2?
No. So a remainder is number A divided by number B whatever from number A is left. So, for example, if you have 20 divided by 4, that equals 5, right?
Yeah.
What is 4 times 5?
20.
20. So there's nothing left. So it will be 20 minus 20, and it will be 0. So the remainder is 0. Okay? But if it was 21 divided by 4, what's 21 divided by 4?
5 point something.
Right, so the whole number is going to be 5. And then the remainder is going to be, well, we started with 21.
21 minus 20.
20. So it's going to be 1. Right?
Yeah.
Does that make sense? Okay.
Yeah.
So if I have 21 divided by 0, or no, sorry, we're not going to divide by 0. If I have 21 divided by 30, what is that going to be?
0.
0, exactly. And it's going to be, well, I started with 21. And what's 30 times 0?
0.
0. I didn't get anywhere with it. So what's my remainder?
Yes, 21.
21 is my remainder. So
but it's strange that it works.
it's how division works. The division is correct. Anytime you divide a number by something bigger than itself, your remainder is going to be equal to whatever number you divide it with. Does that make sense?
Yes, it does.
Excellent. So, all right, so it's going to be, the remainder is going to be 21, and then 21 divided by 10, it's going to be 2, right?
Yeah.
What's the remainder of this?
1.
1, exactly, because it's going to be 2 times 10, it's going to be 20, 1 is going to be left. And then what's 1 divided by 5?
0.
0. What's the remainder of this?
1.
1, exactly, excellent. So it's going to be 2 dimes and 1 cent.
Oh, it works.
Perfect, I'm glad. All right, have a great day.
You too, bye.
Bye.